So welcome to this quick video looking at the rate of nucleophilic substitution on haloalkanes. Now, when we look at this, we're looking at two factors. We're looking at bond polarity, where when we're talking about bond polarity, we're talking about the difference in the partial positive and the partial negative charge. The bigger the difference in electronegativity, the greater the bond polarity. And then we're looking at bond enthalpy, where we're looking at 1 mole of a specific bond in a gaseous compound. But basically speaking, the greater the bond polarity, the more energy is required to break the bond. So before I tell you the outcome to which is the most important factor, let's discuss how these would link. So if we're looking at bond polarity, if bond polarity was the greatest factor when looking at the rate of reaction, we would get the fastest reaction when we have fluorine in our haloalkane for nucleophilic substitution reactions. Whereas if bond enthalpy was our greatest factor, our fastest rate of reaction would be if we had iodine in our compound. Now, if we go back to bond polarity, with this, because fluorine is the most electronegative here, we would have the biggest partial positive charge on the carbon. That would attract the nucleophile more to it. And remember, a nucleophile is an electron paired donor. So here, this carbon would be more susceptible to nucleophilic attack than the iodine. When we're talking about bond enthalpy, we're talking about the amount of energy needed to break the bonds. So the Ci bond is the weakest bond out of all of these. It goes up in strength each time. So the next one is CBr, then it's CCl, and the strongest bonds out of these four is the CF. Now, if we do the practical, where if with the OCR board practical 7.1, the PAG 7.1 part 2, you can use that to simply identify the halogens in an unknown haloalkane, or if you time it, you can also use it to link to the rate of nucleophilic substitution. So if you do that reaction, you will find out that bond enthalpy is the biggest factor, because you'll find that if you've got an iodoalkane, that one will undergo nucleophilic substitution the fastest, then CBr, then CCl, and then CF will be the slowest. So this will be your fastest, and this one will be your slowest. Thank you very much for watching.